Okay, Assalamualaikum and good morning, everyone. Hello, ada orang tak?
Waalaikumsalam.
Okay, so can you see the slide?
Yes.
Okay, so for today we will learn about tensor, more about continuum solid mechanics. Okay, so for today's lecture is about tensor. So at the end of this lecture, you will be able to understand the basic concept of tensors and perform mathematical operation on tensor. So what is tensor? So a tensor can be thought as a linear operator that acts on a vector or a tensor to generate a new vector or tensor. And in solid mechanics, tensor actually represent the quantities such as strain, stress, and elasticity. So we will see more on this in 2 weeks time. Okay. So in books, usually we will write tensor using uppercase letter and then we bold the uppercase letter. So tensor is also can be thought as an array of data. Okay. So last week we have learned about vector. So vector is actually a one-dimensional tensor. Okay, so it's an array of data that has only one column. Okay, so that's a vector or one-dimensional tensor. So a matrix, a regular matrix, can be thought as a 2 by 2 matrix or two-dimensional matrix. Okay. So we have also three-dimensional tensor, which can be thought as a cube, and then this cube can be stacked on top each other to become a four-dimensional tensor. Then we can also stack the four-dimensional tensor next to each other to form a five-dimensional tensor, and so on. Okay. So usually we will use 1D tensor until four-dimensional tensor in solid mechanics, in continuum mechanics. And in special cases, we will use this maybe not in continuum mechanics, but in something else. Okay. So
Sir, mic sir mute.
alamak. Okay, sorry. Okay, so matrix is a n times n matrix. Okay, a second order tensor. So you can, for example, matrix A is a 3 by 3 matrix. So you can do addition. So if you want to do addition of matrix, so you just add each of the element one by one. So before you do addition, you must make sure that the matrix has the same size. Okay. So here A is 3 by 3, B also a 3 by 3 matrix. So you can add them together. So if they are not in the same size, so you cannot add the matrix together, similar to subtraction. So you can also multiply a matrix by a scalar value. So if you multiply a scalar value, you just multiply each of the element one by one with the scalar. Okay. So I think you have learned this before. Slide saya ada kan? Nampak kan? Okay, so these are some of the properties for matrix addition and subtraction. So commutative means you can add A plus B or B plus A. Tak kisah dia punya order. Okay. Similar to associative, if you have A plus B plus C, you can add A plus B first and then plus C, or A plus C first then plus B. You tak kisah order. So we have a zero matrix such that if you add A plus 0, you will get an A, the same matrix A. So the zero matrix has all elements equal 0. Okay. Element tadi semua 0. So A also has a unique matrix minus A, such that if you have A minus A, you get 0. And addition is also distributive, similar to an addition of scalar value. So if you have A alpha plus, times A plus B, so you can kembangkan. Okay, you can expand alpha times A plus alpha times B. Okay. All right, and then if you want to multiply a matrix and add and have addition like A plus B times C, so you can expand A times C and then plus B times C. Tapi order dia tak boleh tukar lah. C times A tak boleh. Okay? So you must A times C. Later on we will see about matrix multiplication. Okay, so identity tensor or identity matrix. So identity tensor I is the tensor such that if you multiply with this tensor, you will get the same tensor or same matrix. So S times I, you get S, or I times S, also you get S. So the identity tensor or matrix is in this form. Okay, diagonal matrix 1, 1, 1, and the other elements are 0. Okay, so transpose of matrix. So transpose of matrix basically you invert dia punya pusingkan dia punya size dia. So the size is m by n. So now if you want to transpose the matrix, you interchange the row and column. Okay, so it becomes n times n. So we use symbol T to represent transpose. So I think you encountered transpose matrix in finite element method. Okay. So for example, A, this matrix, then if you want to transpose, flip in there. Okay. So orang faham kot macam nak flip. Saya faham macam tu. So similar to matrix B, so you can flip the matrix, so you get this if you transpose matrix B. So two important properties for transpose is that if you transpose a matrix 2 times, like A transpose and then transpose again, you get the same matrix, okay, the same original matrix A. And then transpose can be expanded. Okay? So if you have A plus B transpose, then you can transpose each of the matrix one by one. So A transpose plus B transpose. So the properties of matrix transpose will produce this symmetric matrix. Okay. So let's say if you have a square matrix, so square matrix, dia punya size dia row and columns are the same. Okay. So if you have a square matrix A, so a symmetric matrix the properties is A equals to its transpose, A transpose. So you have to um, remember this, okay? So this one is important. Later on, we will encounter more about symmetric matrix in next lecture. So A equals to its transpose. So if you transpose the matrix, you will get the same matrix, okay? So that's symmetric matrix. And then another term is skew symmetric or anti-symmetric. So when you transpose a matrix, then it becomes negative of the original one. Okay? So A equals negative of the transpose of its transpose. So this is also important. This is anti-symmetric or skew symmetric. So these two terms later we will use quite a lot of time. So I hope you take note. Okay. So let's say if you have this matrix above here, this one. So this matrix, if you transpose, you will get itself. Okay. So this matrix is example of symmetric. Meanwhile, this matrix here, the next to it, if you transpose, you will get the negative. Okay, negative of the original matrix. So this matrix is anti-symmetric. So every square matrix A can be expressed as a sum of symmetric matrix and a skew symmetric matrix. So a matrix A uh, can be expressed as this 1/2 times A plus A transpose plus 1/2 times A minus A transpose. So this is important actually. Later in the next lecture, we can express some matrix into two different matrix, which is the symmetric and the skew symmetric matrix. Okay, so example here, given here. Okay. So let's say if you have this matrix, then you can split them. Okay. So tak ada method lah. Okay, there is no method to split this, but this is just an example. Okay. Example that this matrix can be broken up into two matrix. That is one symmetric. So this is symmetric, and the other one is anti-symmetric. Okay, dia boleh dipecahkan kepada dua. So ada kegunaan dia. Nanti kita akan belajar. Okay, so matrix multiplication. So I think you have learned about matrix multiplication masa sekolah. So if you have two matrix A equals m by n matrix and B is a p by q matrix. So if you want to multiply A times B, so you must make sure that the value n here sama dengan same with value P. Okay, size n equals the size of P, meaning that the column of A equals the number of column in B. Then you can multiply. Okay, so if you want to multiply B times A, if you want to multiply B times A, then Q must be equals N. Okay, before you can multiply. Okay, so this is the basic concept of matrix multiplication. So you cannot simply multiply two matrices. You must check the size first. Okay, before you can multiply. Okay, so if you can multiply A times B and B times A, these two matrices are not the same. Okay, will not produce the same matrix. Okay, so A times B is different from B times A. So this is different from regular scalar value. So let's say if you have 2 by 3, it equals 3 by 2. But for matrix, it's different. Okay, so make sure you know about this. And then, so if you have matrix A, let's say A times A transpose, and then power of transpose, another transpose outside, so you can expand this. Okay. Apa ni? Okay, apa again? So if you have, let's say, A times B, if you want to transpose, so you can expand. Okay. So to expand this, you just terbalikkan dia punya order. Okay. So it becomes B transpose times A transpose. Okay, so let's say if you have inverse, so it becomes B inverse times A inverse. Okay, it it will be the order will change. Okay, and then multiplication with identity. So if you multiply with identity, you will get the same original matrix. Okay, so this one is important. So if you have A, B transpose, then if you want to expand, so it start with B transpose first and then times A transpose. So similar to inverse. Okay, so let's look at an example. So let's say if you have two matrix A and B, so A is given by this matrix, and then B is this matrix. So you look at the size of A. So size of A is 4 by 3, and then size of B is 3 by 4. So you can multiply A and B because the number of column of A equals number of row in B. So to multiply, you can use calculator or you can do it manually. Okay. So if you want to do it manually, so if you want to get 36 here, so you just take this row multiply by the first column. So 5 times 3 plus negative 2 times negative 6 plus 1 times 9. So add them all, um, then you get 36. Okay. Betul right? Then you can transpose the matrix if you want. Okay, so you can transpose this matrix. Then you can check whether this transpose is similar to if you transpose the matrix one by one. Okay. So what this actually do is the question wants to check if A times B transpose equals B transpose times A transpose. So you get the same results. Okay, so we go now look at how to inverse a matrix. So given a matrix A, then the inverse of A, we can write it as A power of minus 1. Okay. So not all matrix has inverse. So some matrix doesn't have inverse. So if a matrix has no inverse, we call it a singular matrix. Okay, so if you have inverse and then transpose, so you can transpose first and then inverse. Okay? So you can do this first and then inverse, or inverse first and then transpose, you will get the same results. So to find a transpose of matrix, it equals the adjoint matrix A divided by the determinant of A. So I think you know how to find determinant of a matrix. Okay, so let's look at an example how to do this. Okay, mungkin refresh balik macam nak buat. So let's say if you have this matrix A, so matrix A, so you want to find the inverse of this matrix. So firstly, we find the determinant. So to find the determinant, maybe we can take the first row here. So to get this value, basically tutup this and then cross multiply this. So 4 times 5, 20, minus 3 times minus 3. Okay, so 4 times 5. So we get 29 times 2. Okay, times 2, so you get this. And then plus you tutup ni and then cross multiply. Cross multiply this and this. And then to get the last one, you do the same thing. You tutup ni and then cross multiply. Okay, so to find determinant, you can also do you can also choose a different column or row. Okay, so maybe if you don't want to use the first row, you can use the second row. So how to do that? So you just tutup ni and then cross multiply ni and then repeat plus cross multiply. Okay, but you need to remember to multiply by this number 2, and then like here suddenly has negative. So you I think you still remember that it start with plus here and then minus, plus, and then this minus. Use the second row, make sure that you multiply by -1, okay, instead of positive. Okay, faham kot benda ni. And then after you get the determinant, then you can find the adjoint matrix A. So to find the adjoint matrix A, kita kena cari the cofactor, okay, cofactor. And then before finding the cofactor, you need to find the matrix, the minors, okay. So for example, adjoint A. So I show you the first element only, okay. So to find the first element, so you need to find the minor first, okay. So the minor is the determinant of the first element. So tutup ni and then find this determinant. So that's the minor for M11 or the first element. And then to find the cofactor, you multiply by the positive, the sign, okay, the sign at each of the element. So here the sign is positive times the minor, okay, times the determinant. So the determinant you multiply dengan number, but for the cofactor you only multiply with the dia punya sign only. Okay, later on you will we will see how to do this. Okay, of function like symbol, for example. So you can use calculator anymore. So you need to use manual calculation of inverse. Okay, so this is just example. So I hope you can rebrush balik lah kalau tak faham. Okay. So in the end, we get this inverse matrix. Okay. Oh no, this one. Okay, silap. Bila semua boleh pakai calculator, buat apa nak kira manual, kan? Betul tak?
Betul.
Tapi in some cases lah kita akan guna untuk kira manual. Okay. Okay, so determinant. So tadi kita tengok the inverse. Okay. So now let's look at the properties of determinant. So let's say if you have two matrix A times B, and then you want to find the determinant of A times B. So you can just find determinant of A and then times determinant of B. Okay, so sebenarnya properties of determinant ni dia ada banyak. Okay. Properties of determinant ni antara yang kalau dulu belajar famous lah soalan ni, memang pengsan, student pening tak ingat semua. But we will look at some of the properties. Okay, so uh, kalau always can refer to notes lah. Okay, let's say keluar exam ke, tapi tak adalah tanya. Okay. So if you have matrix A transpose, so the determinant of A transpose is the same as the determinant of the original matrix A. So if you transpose a matrix, determinant dia still sama. Okay, so number 2 ni is actually important properties of matrix. Okay, later on we will see why this is important. So if you transpose a matrix, you will get the same determinant. So if you have a scalar value alpha times a matrix, so if you want to bring this out, so it becomes alpha power of n. So n is the order. Order maksudnya kalau 2 by 2 matrix, the order is 2. So if a 3 by 3 matrix, then order is 3. So remember, one of the important things is that determinant is only for square matrix, okay? Ataupun m by m matrix. Dia punya size column and row sama. Okay, so other matrix like m by n matrix yang bukan square, dia tak ada determinant. Dia tak ada inverse saya rasa. Tapi biarlah. Okay, so another thing is that if you have a I think this is inverse. Tak apa, abaikan nombor 4. Okay, so from 4 to 7 is actually the properties of determinant yang saya cakap tadi, yang pening kepala tadi. So one yang ni penting tapi important in manual calculation, but usually we don't do manual calculation of determinant. We will use calculator. So the most important properties of determinant is number 2 and actually number 1. Okay, we will use this a lot later. Even though we use calculator, this is important properties. We will look at this more in next lecture. So another tensor, another type of tensor. So just now we have learned about symmetric tensor and anti-symmetric. So another type of tensor is orthogonal tensor. So an orthogonal tensor is a tensor when it is acting or multiply on a vector, it will cause the vector to change in direction only, but not the magnitude. Okay. So for example, if you have x, the magnitude x, if you multiply the vector with the tensor, then the magnitude is the same, but direction dia bertukar. Okay. So the properties of orthogonal tensor is that if you have q times its transpose, so q times q transpose, you get -1. Identity matrix. Identity matrix. So just now symmetric matrix, if you have A, then it equals to A transpose. But now for orthogonal matrix, you have q times q transpose equals identity matrix. Okay, or you can write it q equals q inverse transpose. Okay, So tak sama. So antisymmetric is A equals minus A transpose. Okay, so these three properties are important later in next lectures. Okay, there are so many properties of a matrix that cause deformation of something that is actually has properties of orthogonal, symmetric, and antisymmetric. Okay? Okay, another properties of a tensor or a square tensor is the trace. Okay, so trace of a tensor is the sum of the diagonal elements. Okay, so for example, if you have tensor A, matrix A, so to find the trace of A, so you just add the diagonal element values. So 4 plus 2 minus 4 equals 2. So trace of A equals 2. So this is important. What is trace? Okay, so trace is just the sum of the diagonal element of the matrix. Okay, so it's a square matrix for square matrix only. Okay, so trace adalah satu properties of matrix yang important. So I hope you understand or hafal ke, trace of matrix is the sum of the diagonal element. Okay, so this is an exercise. Maybe you can do this later. Kalau ada masa kita discuss next week. Okay. So calculate A plus B plus A. So you can do this by calculator. Okay. So I think this is simple je. Okay. You can do it by yourself. Okay. Jawapan tak ada lah. Boleh try guna symbol lab ke to check. Okay. And then exercise number 2, you can also do this by yourself. Maybe next week I will show you how to do this manually, okay, and use calculator. I think I'll give you YouTube video in WhatsApp how to perform inverse using calculator, or you can just search YouTube how to do this using calculator. Let's say if we end up with face-to-face exam, so you don't have a laptop, so you have to use calculator to find the inverse. Okay, so always use calculator. Saya tak galakkan kira manual, okay? Dia akan menyebabkan awak bazir satu muka surat dalam kertas. So you just use calculator to find inverse. Okay, now let's look at another properties of a tensor, which is the eigenvalues and eigenvectors. So a tensor can also be thought as an operator, macam satu operator that changes a vector into another vector. So for example, the orthogonal tensor just now, it causes the vector to change in direction, but the magnitude remains the same. So if you multiply a tensor to a vector, then that vector will change in something, either direction or magnitude. So there are certain vectors that when you multiply with a tensor, the length or the magnitude doesn't change. The magnitude change but not the orientation. Okay? The direction tak berubah. So just now the magnitude doesn't change but the direction change. So that's orthogonal matrix. But some tensor, if you multiply with a vector, it causes the vector to change in shape or the length, but the direction remains the same. So if that kind of vector exists, then it must satisfy this relationship here. So A times a matrix, matrix A times a vector equals a scalar value times the same vector, meaning that the magnitude has changed. Okay, so A is the tensor and lambda is a scalar value. So here from this relationship here, the vector n and the scalar lambda are known as the eigenvectors and eigenvalues respectively. So n is the eigenvectors and lambda is the eigenvalues. So we will look later how to determine the eigenvectors and eigenvalues. and why we need to determine this thing. Okay, so we can rearrange the original equation. So a dot n equals lambda n. So you can write this into this. So you can write a dot n minus lambda n equals 0. So because this is a matrix and this is a scalar, so you can write them by adding the term identity matrix here to make them uh, in the tensor form, okay, in matrix form. Because here is a matrix, but lambda is a scalar, so they have different size, okay. Size dia tak sama. So to make the size of lambda and a the same, so you multiply by the identity. Okay, so ni just derivation, okay. Bukan pengiraan lagi lah. This is just only the derivation. So when you have a dot n minus lambda times identity matrix I dot n equals 0, so you can factorize. Okay, so factorize a minus lambda I dot n equals 0. So here we have this equation here. So this equation is important. Okay, the second one here. So we call this equation as the characteristic, not characteristic yet. Okay? This equation is important. Okay? Later we will see why it's important. So the equation will always have the trivial solution n equals 0. So to solve this, when you put n equals 0 or n is a 0 vector, then you get the solution. Okay? But what we want is we want to find the value of lambda here that makes this uh, uh, factor here equals 0. So we want to find the value of lambda. So to find the value of lambda, then the only way is the matrix A minus lambda I is a singular matrix. Okay, so a singular matrix, as I said previously, a singular matrix is a matrix that has no inverse. Okay, so when a matrix has no inverse, meaning that the determinant equals 0. So to find the value of lambda, we can just find the determinant of this whole matrix here and then equal it to 0. Okay, so you find the determinant. So this is the determinant. So lambda is only on the diagonal element. So here you have minus lambda because it is on the diagonal element. And then find the determinant equals 0. So from here you expand the determinant, then you can find the eigenvalues lambda. Okay, later we will see an example how to do this. So when you find so when you find lambda, then you can find uh, the matrix, the vector n by substituting back into the original equation. Okay, so later we will see an example how to find lambda and how to find the vector n. Okay. Okay, so example ni panjang. So let's say the question asks you to find the eigenvalues of eigenvalues and eigenvector of tensor B. So B is given here. So usually kalau dalam if you want to do this in laptop ke, you can just use MATLAB or Symbol Lab. But in exam kena kira manual. Okay. So firstly, we find the eigenvalues first, which is the lambda. Okay. So eigenvector is the n, the vector n. So first we find the eigenvalues by substituting into the equation earlier. Okay. So the equation earlier is a minus lambda I. So here in this case, A equals B minus lambda I, and then find the determinant. So determinant of B minus lambda I. So you just calculate B minus lambda I. So 1 minus lambda, 2, 4, 1, and then again 1, 1 minus lambda, and then 5, 1, 1, 5, 1, 5, and then another, the last one here, 1 minus lambda, and then find the determinant equals 0. So you calculate the determinant manually. So expand the determinant equals 0. Rearrange, so you get this equation here, cubic equation. So if you have a 2 by 2 matrix, you will end up with a quadratic equation. Okay? But if you have 3 by 3 matrix, you end up with cubic equation. So from here, you can find the value of lambda by factorize lambda. Okay, or you can use calculator for this one to find lambda. So here dia guna calculator lah, dia tak tunjuk lah macam nak kira. So lambda equals 0, 7 and minus 4. Then you need to find the eigenvectors after you find lambda. So each lambda, lambda 1, lambda 2 and lambda 3 has its own eigenvectors. So we have n1, no, we have n for lambda 1, n for lambda 2, and also n for lambda number 3. Okay, so to find n, we substitute back each of the eigenvalues into the original equation here, this one. Okay, so example here, using the first eigenvalues, which is 0. So you substitute lambda with 0 times the vector n equals 0. And then expand this, you get 3 simultaneous equation. Buatlah macam mana nak solve, and then you end up with this value of n. So you find n1, n2, and n3. So you will end up with this n. Okay, so this is n1, n2, and n3. And then repeat the process for different lambda block. Okay, so lambda number 2 equals 7. So you repeat the process. So you get n for eigenvectors for lambda equals 7, this one. And then repeat the process for lambda number 3. Then you get the eigenvectors. Okay, so you have, if you have a 3 by 3 matrix, you will have 3 lambda and 3 eigenvectors n. Okay, so if you have 2 by 2 matrix, you have 2 lambda and 2 eigenvectors. Okay, so ni tak tahu lah macam mana dia cari. Okay, tadi saya cari YouTube macam mana nak guna calculator, tak jumpa lagi. So later if I found from YouTube how to use calculator to find eigenvalues and eigenvector, I will share to you guys. Okay, so ni bila you have this 3 simultaneous equation yang macam ni, dia jadi macam otak terberhenti sekejap nak solve. Okay, macam mana nak solve ni? Okay, selalunya dia akan end up equation yang simple. Okay, but maybe because of this matrix B here, then you will end up with this matrix. But you can always find eigenvalues and eigenvectors using Symbol Lab or MATLAB. Okay. Okay, so this is an exercise. So you can try this first. Maybe we can discuss this next week, how to do this. I think this one you will end up with a simple equation. Okay? So try to find eigenvalues. So if you know how to find eigenvalues, that's okay. Then try to find eigenvectors. So I think finding the eigenvectors is susah sikit berbanding finding eigenvalues. Okay, let's look at another properties of a tensor. So just now we have looked at properties like trace, symmetric matrix, antisymmetric, orthogonal, and also eigenvalues. Are also important. Okay. So invariance of a tensor are scalar functions of the tensor in which the values remain constant under basis transformation. So for example, if you look at this figure here, these two purple colored vector here are the same vector. Okay, they are the same, having the same magnitude and direction. But if you measure the vector using different coordinate system, for example, if you have let's say this one is XYZ, for example, and then this one maybe you use um, cylindrical coordinate system, for example, tak tahu belajar ke tak. So let's say you use x1, y1, z1, different coordinate system. Okay, if you measure this vector using a different coordinate system, there are something in the measurement that is not changing. Okay, the value doesn't change. Okay, some of the properties of the measurement. Okay, so that properties is called the invariance. So invariance means something doesn't change. Okay, or properties that will remain the same even though you look at the vectors at a different angle. Okay, or at a different point of view. So you can imagine uh, the purple color line here and the red color line here as your point of view. For example, if you look at a car moving, okay, let's say if you have a car moving on a road, let's say you look at the car from the front, okay, and then one of your friend look at the car from the back. Okay, maybe you look at the car is moving faster approaching you, but your friend looking at the car moving faster but going away. Okay, so you look at the car and the way your friend look at the car is different. Okay? Are different because of the point of view, but actually the car is moving at the same speed and also at the same direction. So the speed and direction are the same, but the way you look at the car causes the way you interpret the car direction and magnitude differently. But there are something on the properties of the car movement that remains the same between the both of you. Okay, so that thing that remains the same are the invariants. So in a tensor, the properties of invariance are, for example, the eigenvalues. So the eigenvalues of a tensor are invariants, and then the determinant of tensor is also an invariant, meaning that if you have, let's say, matrix A, and then you find the transpose, then if you want to find the determinant of A, the determinant of A is also equals determinant of A transpose. Okay, so even though you transpose the matrix, the determinant is the same. So that's invariant. Okay, maksudnya determinant dia sama je walaupun you buat macam mana pun pada matrix tu. And then another properties of invariant, one example of invariant is the trace. Okay, so the trace of matrix A will be the same for A and A transpose. Okay, so later in continuum mechanics, in real lecture later, we will see some invariance. We need to calculate the invariance because from the invariance, when we can determine the properties of a deformation, for example. Okay. So let's say if you have a tensor S, so we can find eigenvalues by using the determinant S minus lambda I. So from previous slide, then we can expand this. So from this cubic equation here, lambda 1 is the trace. Okay? So trace also the sum of diagonal element, or it's equals to I1 here from the determinant equation. And then I2 is this formula. And then I3 is the determinant of S. Okay. So this I1, I2, and I3 are the invariants, another invariance for the matrix, okay, for the tensor. So if you expand this determinant of the matrix, you'll get this equation in cubic form. So I1, I2, and I3 are the invariants. Okay. Don't worry, later when you do the exercise and when we discuss it next week, we will see what I mean by I1, I2, and I3. Okay, so another important properties of matrix is a diagonalized matrix. Okay, so a diagonal matrix is a matrix or a tensor that all elements are zero except the diagonal elements. So example here, so the first tensor here is a diagonal matrix. So we have values at the diagonal element 1, 8, 4, while the other elements are 0. So when you encounter this kind of matrix, it is a diagonal matrix. So the most common diagonal matrix is the identity matrix. Okay, because we have value 1, 0, 1 at the diagonal element and 0 at the other elements. Okay, so I is a diagonal matrix. So sometimes it is important if we can diagonalize a matrix. So it is desirable to represent a matrix by a diagonal matrix, because operation on matrix involving diagonal matrix is much more simple compared to if you want to multiply this symmetric matrix here. So if you have diagonal matrix, it's much more simple if you want to expand and so on. So for example, if you have this matrix here, -3, 0, 0, 0, 4, 0, 0, 0, 7, and then you want to find the inverse. So you don't have to find the determinant, the adjoint. So you just inverse each of the element. -1/3, 1/4, 1/7, and the other elements are 0. Okay, so you just powerkan je. So let's say if you if you want to find this matrix power of 8, for example, so it becomes -3 power of 8, 4 power of 8, 7 power of 8. Okay, boleh terus powerkan je. Tapi if you have one element here equals to a number not equal 0, then you have to do something else. Tak boleh terus powerkan. Okay, so you can power the element if your elements are on the diagonal matrix. Okay, on the diagonal element, or your matrix is a diagonal. Okay, so diagonal matrix is also important. Okay, semua pun important. Okay, so diagonal matrix is important. If you do finite element method, let's say FYP ke, if you realize that in your software, actually the software is trying to make sure that your matrix can be split or can be rewritten in terms of diagonal matrix. So instead of software to solve the matrix simply inverse membuta tuli, dia diagonalkan dulu sebab lagi cepat berbanding dia nak inversekan a normal matrix. Okay, so in computer or in MATLAB ke, they will always find the diagonal matrix. Okay, but you tak tahu lah proses tu. Okay, komputer tu tak tunjuk lah the process of finding diagonal matrix, but actually the computer will perform diagonalization. Okay, a process of diagonalizing a matrix. So this is how actually a computer perform diagonalization. Okay, so we can do diagonalization or a process when we diagonalize a matrix. So to diagonalize a matrix, basically we need to find the eigenvalues and eigenvectors. Okay, so for example, if we have this matrix A, then if we want to write this in terms of diagonal matrix, only has this element, but the other elements are zero. So first thing that we need to do is to find the eigenvalues. So we need to find the eigenvalues of A first. So to find that, we use determinant. Determinant A minus lambda I equals 0. And then from here, we get lambda equals 1, 1, and 2. And then somehow you solve this to find the eigenvectors. Okay, so you get eigenvectors n1, n2, and n3. Okay, later when you do the exercise, you try lah macam mana nak solve dia pakai calculator. Okay, YouTube ke? Okay, guna YouTube, check kat YouTube. Okay, so when you find the eigenvalues and eigenvectors, then you can express matrix A as follows. Okay, so to diagonalize a matrix A, you can write P minus 1 times A times P equals D. So D is the diagonalized matrix. Is the diagonalized matrix. So how to find D? So to find D, basically you just use the eigenvalues of A. So just now lambda equals 1, 1, and 2. So to find the matrix D, you just susun this value lambda on the diagonal element of the matrix D. Okay, so you just susun here 1, 1, and 2, while the other elements are 0. So this matrix, we write it as matrix T or diagonalized matrix. Now we have find the matrix D. Then we need to find the matrix P. Okay, so matrix P can be constructed using the eigenvectors. So just now eigenvectors is n1 equals 1, 1, 0, 1, 1, 0, 0, 2, 1, 1, 0, minus 1, 0, 2, 1, and 3 is 1, 0, minus 1. So to find matrix P, you just rearrange these three eigenvectors into the column of matrix P. So let's say if you use this lambda 1, then the first column of P must be n1. And then here n lambda 2, this is n2. So lambda 1, lambda 2, lambda 3. And then this is lambda 3. And this is also n3. So you can interchange the location. Okay? So let's say if you use, if you define D as 2, 1, 1, for example, then P becomes 1, 0, minus 1, okay, n3, because this is lambda 3, this is n3. And then let's say this is lambda 1, so you have 1, 1, 0, and then 0, 2, 1. Okay. So susunan dia bergantung pada kat mana awak susun lambda ni. Okay, so kalau this is lambda 1, and then this column will be n1, lambda 2, n2, and so on. Okay, so make sure you arrange them accordingly. Okay, then if you use calculator, P minus 1 times A times P, you will get D. Okay, okay, tak ada order yang preferred as long as susunan dia sama. Okay, So to find the diagonalized matrix of A, you have to find eigenvalues and eigenvectors, and then rearrange the values of eigenvalues in matrix D and eigenvectors in matrix P. Okay, so you just rearrange je. Tapi nak cari eigenvalues and eigenvectors tu yang problematic sikit. Okay. But later when you do the exercise, I hope you understand how to find these values. Okay, so polar composition, this one we will encounter later, but for now we can skip this part. Okay. Okay, so exercise number 4 is about diagonalize a matrix. So when you do exercise number 3 just now, then you can continue do this exercise. Okay, it's the same question, but now you need to arrange the matrix D and P minus 1. But the important thing is this S power of 8, how to find S power of 8 just from this. Okay, so I will show you how to do this. Okay, so we have P minus 1 S times P equals D. Then if we can rearrange this, we can get S equals, okay, so you just times P here. So if you times P at in front here, then you must times P in front of D. Okay, so why you times P? Because you want to cancel this. Okay, so P times P minus 1, you get identity matrix. Okay, so for the other P here, you multiply by P minus 1. So when you multiply by P minus 1 here, you also multiply P minus 1 on D. Okay, so this one becomes identity. So S equals P D P minus 1. So how to find S power of 8? So S power of 8, basically you multiply S 8 kali, okay? Kalau nak kira manual, pengsan lah. Okay, pakai calculator boleh juga. But what happens if you want to do this manually? So you have to multiply 8 times, okay? So basically you write P D P minus 1. Okay, 8 kali. Okay, you write this 8 times. So what happens is that this P and P minus 1 and P can becomes this identity. Okay, basically hilang lah. So what happens? It becomes P D D D D D D D D P minus 1. Okay, ada 8 kali D. Or you can write it in terms of power je lah. Okay. So to find S power of 8, basically you just find P D power of 8. So D is already a diagonal matrix. So let's say you have lambda 1, lambda 2, lambda 3 for matrix D. So if you want to find D power of 8, so simply power of 8 each of the lambda. Okay, so tak perlu kira matrix multiplication one by one. So now you just need to find P and P inverse. Maybe use calculator boleh, or if you want to do it manually, then just multiply with D power of 8. Okay, so I want you to try this at home. We will discuss this next week, inshallah. So I think that's it for today's class. Any question? Okay, so another one is the to find the diagonal matrix is also in your sample midterm. Okay, so you can look at the sample and try to do the exercise. Okay, so yang ni juga keluar dalam midterm and also final exam later. So try to do the calculation for eigenvalues, eigenvectors, and also perform writing the diagonal matrix and also the P matrix, P inverse and the P. Okay, so that's it for today's class. Any question? So if you have no question, we will discuss this exercise inshallah next week. And next week we will go into learning about calculus pula, okay? Before we can go into going into continuum mechanics. Okay, so that's it. Okay, before that, sebenarnya nak beritahu pasal project ni sekejap project. So we have midterm 20%. So I think midterm will be on week 7. And then we have project 20%. So for the project, actually I've divided into 2 parts. So 10% you will use MATLAB, and another 10% is I will arrange some talks, okay, from people that use continuum mechanics in their research, okay. So there will be, I think, 3 talks. So first from me, and then second one from someone from UMP, and then the third one is from outside UMP. So we will learn from them how they use continuum mechanics in their research. So there are variety of applications of continuum mechanics in research. For example, we can study material failure, material fatigue, for example, and we can also study biomechanics using continuum mechanics. So each of these presentation, there will be marks, okay. So later I will give you the date, maybe after midterm, okay. So marks are from attendance. So if you don't attend the talk, automatic 0, and then there will be some question or macam tulis essay ke, essay ringkas what you understand from their presentation. And then we have final 60%. So I don't know when is your final. So later I will check. Okay. Tak tahu bila. Okay, so that's it for today's class. See you next week, insyaAllah, on Thursday. Assalamualaikum and goodbye.
Thanks.
Thank you, sir.
Yes, sir.